How's it going, everybody? In this video, we're going to cover, discuss, and show how VRF Lite works. Now, if you're not familiar with VRF Lite or Virtual Routing and Forwarding Instance Lite, basically what a VRF is simply an additional routing table that you create on a router. Now, if you are familiar with a layer 2 switch or even a layer 3 switch, if you create a VLAN and you have VLAN 1 and you create VLAN 2, they are two separate broadcast domains. That's the idea of a virtual local area network. You split the switch up into, you virtualize it, so you have the port. You can put ports into different networks, and they don't talk to each other and things like that. So the idea behind the VRF is you do the exact same thing. So let's say, for instance, you need to put certain ports into certain routing tables, and you need to carve up the routing table. So let's say, for instance, you have a compliance issue, or you have some sort of need where you need to prevent a certain type of traffic or a group of subnets from being able to talk to each other completely. So let's say, for instance, you need to run your wireless infrastructure completely separate from the rest of the company's infrastructure. So you can run the company's wireless alongside the same exact or I should say, on the same exact hardware as your production traffic and your management traffic and your security and all other stuff can all be ran in the same box, but into a different routing table. It's a virtual way to cut up the routing table and put different ports in different routing tables. So if you're familiar with creating a VLAN on a switch and putting a port into a VLAN, you're doing the exact same thing on a router. You create a VRF, you put a interface into that VRF, and now that interface no longer belongs to the global routing table. It is now moved into the into the VRF you've created. So if you type in show run interface whatever it is, you're going to see that it's either going to have a IP VRF forwarding or VRF forwarding, depending on the syntax you're using. What we're going to take a look at doing here is we're going to create a VRF on router 1 and 2, and what we're going to end up doing is we're going to create the VRF so that you guys can see exactly how this will play out. And we're going to use the IPv4 and IPv6 capability of VRF definition. And what VRF definition does is it allows you to activate certain address families, because definition is going to be both v4 and v6 compatible, where IPVRF is only IPv4 compatible. So if you run, we eventually will run IPv4 end-to-end on every protocol, top to bottom, and then we're also going to run IPv6 because it's still pretty applicable as we go through. So with IPv4 and IPv6 being able to be ran at the same time, that's why I'm going to use the VRF definition keyword and command, and then we're going to put some interfaces into some VRFs. Now the nice thing about this is you might be thinking, well, if I only have two physical interfaces, how do I take one interface and put into a VRF, the other guy goes into another VRF? Well, that's the nice thing about this is when you are dealing with going through and dealing with what's the word I'm looking for? When you are dealing with sub-interfaces, you can actually take a sub-interface and put the encapsulation on it and have the trunk links be running between two routers. What you can actually do at that point is you can go in and you can put a sub-interface into a VRF on a per sub-interface basis. So let's say, for instance, we create fast 2/0 dot 12, for instance, for VLAN 12. So we create that, and then we create an IP address that's specifically for that sub-interface, that trunking connection between 1 and 2. We're going to then put those two sub-interfaces, one on router 1 and one on router 2, in the same VRF. Now the VRF naming structure is locally significant to the router. All that they care about is making sure that the route distinguishers match, and the route distinguisher is going to be used to make the route unique. So as you go through, and you'll see it's very, very straightforward to get things to show up, and you'll see it's relatively straightforward to verify. It's just that the show commands that you use are going to be just a bit different, and I'll show you what those look like coming up. And in a later video, I will show you how to deal with some of the other things like easy virtual networking and what they refer to as VNet trunking. Those will be coming into a later video, but I wanted to cover at least VRF Lite in a very, very basic implementation, and then I'll follow this one up later on with a easy virtual networking and a VNet trunking, and some other capabilities that are out there for virtualizing your infrastructure. So the first thing we're going to do now is we're going to jump over to our GNS3, and we're going to pull up our configuration. And as you can see on router 1, we have this guy set up. So on fast 1/0, we're going to exit out of here and type in interface fast 1/0 dot. I'm going to say dot 12. Okay. What I'm going to do is I'm going to type in encapsulation dot 1Q 12. Okay. This way here, there's a sub interface now. Now what I'm going to do is I'm going to exit out of here, and I'm going to type in VRF definition. Now definition is going to allow me to do both IPv4 and IPv6 traffic forwarding. I'm going to type in VRF. VRF Lite, just so that it's something that you guys can associate to. I'm going to hit enter. I'm going to type in the route distinguisher is going to be, we'll say 1:2. And the reason I say 1:2 is because we're peering between router 1 and 2 with it. I'm going to hit enter. Then you have to go to address family IPv4. Now, by typing this command in here, you're actually activating the address family to allow it to forward. If you do not do this, then you will not be able to actually apply the VRF to the interface because there won't be an address family for it to apply to. And then here, you can do other things like route target values, and these are things for like MPLS layer 3 VPNs, where you want to determine which provider edge routers are going to be able to send and receive traffic. But I'm not going to get into route target values. I just want to make sure that we can go from here. The next thing we're going to do is we're going to say is address family IPv6. I'm going to activate it now so that later on it's already done. We could just go ahead and just kick it right out. I'm going to do the exact same configuration on the other side. Now if we would type in do show run VRF, here we have it. Now what I get to do here is I actually get to go over here and I get to copy this information over to router 2. Whoop, that's not what I wanted to do. So I'm going to copy this information over to router 2, and this way here you guys can see how this actually applies. And then we're going to apply this to so I applied that to the router. I'm going to exit out of here, and what I'm going to do next is I'm going to go to interface fast 2/0 dot 12. Type encapsulation dot 1Q 12. Okay. Now what I'm going to do is I'm going to go, since I'm underneath the interface, I'm going to type in VRF forwarding is going to be VRF Lite. Okay, so now I've moved that from the global routing table into the VRF Lite forwarding table. So let me go over to router 1. I haven't done over here. So I'm going to type in do show IP route connected. Okay, and if you see right, I don't have an IP address configured to it yet, but this is the global routing table. Okay, so what I'm going to do is I'm going to type in, I'm going to exit out of here. I'm going to type, actually I haven't placed the interface in there yet. I have to type in an IP address first. So I'm going to exit out of here. I'm going to type in interface fast 1/0 dot 12. I'm going to type in IP address of, we're going to type in 12.0.0.1 with a 24-bit mask. So if I do show IP route connected now, okay, see now the guy shows up here, right here, and it's in this interface, right? Now if I go to the, if I type in VRF forwarding, VRF underscore Lite, hit enter. Now it's telling me that I need to move it to the other interface. So I need to replace the IP address. I'll type the IP address in. Now I do a do show IP route connected, and now it's gone. Now if I do a show IP route VRF underscore Lite, there's the interface. Now I've placed it underneath the same interface. And now on router 2, I get to do the exact same thing. I need to type an IP address of 12.0.0.2 with a 24-bit mask. Okay, now that I've done that, I'm going to type in do show IP route VRF Lite, and there it is. I'm going to type in do ping, and the interesting thing about when you're configuring this is you actually have to use the VRF commands. There's two ways of doing this. Do ping VRF Lite, and then 12.0.0.1. Okay, I can ping through the VRF, and that's because I'm pinging through the VRF. Or you can type in, I'm actually going to exit out of this. I'm going to type in, what is that, routing context, and then the VRF and the VRF name. So it's supposed to be under VRF. So it says on router 2 you're in the VRF Lite configuration, and now I can do anything I want under here. I can do all the configuration I want on a per VRF basis, and now I get to do a show IP route without having to append the show IP route VRF Lite command. So now I get to type in ping 12.0.0.1, and I can ping it. So now I get to exit out of here, and now I'm back to the global routing table. So I went into the routing context of the VRF, and I'm good to go. So now that I've done that, I can go in now and I can create a OSPF adjacency. Now this OSPF adjacency will be all on its own. It will be completely separated from the rest of the adjacencies. And the reason why this is going to happen is because of the fact of the way that the VRFs work. When you create a VRF, you've created a completely separate routing table. So now what I get to do is I need to go into here, type in interface fast 2/0.12, and type in IP OSPF, and then the process ID number we're going to say is 1. I'm going to type in area 0. Now I'm going to go out to the other side. I'm going to go to router 1, and I'm going to create router 1. I'm going to type in interface, or I'm already under here, so I'm going to type in IP OSPF 1 area 0. Okay. Now we'll see an OSPF adjacency pop up. Now one of the first things I'm going to do though is I'm actually going to exit out of here. I'm going to type in interface loopback 100. I'm going to type in VRF forwarding is going to be VRF _Lite. Okay, I'm going to put it loopback 100 into the VRF Lite. I'm going to type an IP address of 100.0.0.1 with a /32 mask. So I type in do show IP route VRF Lite connected. You'll see that I have both interfaces in there. And then what I'm going to be able to do now, and the OSPF adjacency now came up. Since I'm underneath the interface for the loopback, I'm going to be able to hit the up arrow a couple times, and I'm going to be able to put this guy into OSPF as well. Now I'm going to go over to router 2 and do the exact same thing. I'm going to type in interface loopback 100. I'm going to type in VRF forwarding is going to be in VRF _Lite. I'm going to type in the IP address of 200.0.0.2 with a /32 mask. And I'm going to hit the up arrow a couple times to get the OSPF configuration. And now if I type in do show IP route VRF _Lite, this is what I'm going to see. Now I have an OSPF route, and this is per VRF. Now if I type in do ping VRF _Lite, and I ping 100.0.0.1, I'm going to be able to reach it. Even if I source it off my loopback 100. I'm going to be able to source it because I'm sourcing it off of 200.0.0.2. The reason for that, if I type in do show IP route VRF _Lite, I'm going to be able to see my OSPF adjacencies. And so there we have it. So now we have everything being advertised. If I do a do show IP route in the global table, I have nothing going on. If I type in do show IP or do show run pipe section OSPF, it's going to show up in the global process. But you're going to see that it actually will append and see that it's router OSPF 1 VRF Lite. So this would be the same thing as me going to here and type in router OSPF 1 VRF and then the VRF configuration. Now I get to do whatever I want to do. I can go into and do anything I want in this VRF are going to be applicable as if there was in the global routing table. The only difference is I went underneath the VRF Lite. So it's completely separated from the global routing process. So if I was to go, when we get into OSPF, I can form adjacencies between these between router 1, 2, and 4, just like I did between 1 and 2, but it'll be in the global process. There won't be any issues with route leaking or routes that shouldn't be learned in the VRF being learned in the global table, and vice versa. The reason for that is because they're two completely separate routing tables. And this is how you could separate or carve up your different traffic, but depending on what it is. And I just had to do this just a few months ago with a client where they needed to separate their their management traffic and their what was the other thing that they needed done? They had some critical third-party stuff running on, but they didn't have any money to buy any additional infrastructure, and they needed a way to do that. And I said, well, you could do a bunch of VRFs, and you could route traffic this way. And then what I ended up doing was, once it was all said and done, and the routes were going where they needed to, because they had a vendor on site that they needed to have their own test network. But like I said, they didn't have any money for additional infrastructure and things like that. They needed to use the existing network to support it. We went ahead and got everything else situated. So all I did was I went in there, created a VRF, I put things into the VRF that needed to be there, routing worked between the two buildings, and things were up and running. And what they eventually did was they said that they wanted to be able to get just the internet in for a particular route, and all I did was I created it was a route leak into the VRF from the global internet, so they would be able to receive internet. But they weren't able to talk to any of the additional networks, so they weren't able to go from the VRF to the global routing table to talk to any of the company's internal networks. They were able to go from just the VRF out to the global internet, because basically what they had to do is they had to do some uploads to their company's network, and we created a VPN between them. And it was actually really, really simple to do but it took me some time to go look up the commands. So that's the only thing that was time consuming. But that's a really, really corner case scenario for like bringing the internet in, at least in my experience. Not to say that it is impossible to be done. It's definitely it's pretty common to see the internet being route leaked into a VRF from the global table. And towards the end of our series, for like additional bonus videos and stuff like that, I'll probably do things like that. But for right now, this is just for you guys to understand the whole concept of VRFs. And in my opinion, you shouldn't be afraid of VRFs. VRFs are a very, very simple thing to understand, because I put the relationship to them the same as those of you that have got a CCNA and you're familiar with VLANs. At least you should be familiar with a VLAN. That the VLAN carves up a layer 2 switch into multiple logical networks. That's exactly the same thing that a VRF does. So putting relevance is something you already know. It makes it really easy to understand. Instead of me trying to explain it, I'll break it down, draw it all out. So, assuming you already knew that. So, like I said, a lot of this stuff is pretty straightforward. And now we're currently underneath the VRF configuration on router 1. If I was to go under here and type in router OSPF 1 and hit enter, if we do a do show run pipe section OSPF, you will quickly see that I'm using process 1 underneath the VRF. I could also use process 1 underneath the global process. And again, why is that? You guessed it, two different routing tables. They don't see each other. So that's the idea behind them. So there's a lot of capabilities that you'll see that are going to overlap. So I'm not going to go into an extreme amount of detail on how this stuff works, but if you understand this concept here, if you were to take this a step farther, so beyond what I've shown you here, this should be pretty straightforward for the most part. Like I was mentioning, once you get into the MPLS piece, you'll take this a step farther with route targets and stuff like that, but that's for MPLS VPN. As far as I know, you could use a route target if you're going to do VRF route leaking, going from one VRF to another. Now that's more of an advanced topic, and we'll talk about that more towards the end of the series, but to cover the core concepts, and all I'm doing basically is I'm going through the line items and covering the topic, just so you guys are familiar with it. And I'll go in there and I'll cover VNets and trunking and things like that down the road. But at the end of the day, that's pretty much what VRF Lite is. It's the ability to go in there and... Oh, I'm sorry, I forgot one thing to show you guys before I cut you guys loose. it is I've shown you the routing table. So let me do this now. If I do a show IP route OSPF, or sorry, show IP OSPF neighbors, it's going to come in underneath this guy. If I do a show OSPF v3 1 IPv4, I think it will also work. Neighbor. Okay, so no, it won't. So show IP OSPF interfaces, or sorry, interface brief. It's going to show you the interface is running, but the unfortunate part of it, it doesn't give you any idea of what global process is running and does it. So, or I'm sorry, show OSPF. Is OSPF an option? Oh yeah, it is. OSPF. OSPF IPv4. That's what I was looking for. Show OSPF and then interface brief. Okay, yeah. See, it's funny how that works, but interesting. Let's go neighbors. IPv4 neighbors. Yeah, that's weird that it does that. I would think, you know what it might be? It's this right here, because I should be typing OSPF v3 and I'm not. So that's probably what the problem is there. So show IP OSPF neighbors, and there we have it. So because of the fact that it's IPv4 related, and the other one is IPv6 related with the IPv4 address family. So, but that's pretty much the breakdown to it. So, I hope this has been informative for you. There's a question. What about the OSPF database? Good question. Show IP OSPF database. And you're going to see this come in, and that's actually a really good point, because it still doesn't tell you. I guess that would mess with you if you didn't know how to how that would work. So yeah, I think that would mess with people, to be honest with you. So yeah, that's actually a really good point. I didn't even think about that, to be honest with you. For the network, yeah, that's it right there is your network link state. That is going to be your type 2 LSA. So we do it for the advertising router. So router this guy is your ASP, or is your DR. So we type in show IP show IP OSPF neighbors. You'll see that 2 is the DR. That's why it's showing up. If you do the same thing on 2 and jump out of here and do a show IP OSPF database, 2 is the ASP, or 2 is the this guy, and then if you're to do for the this guy, or for the router, and hit the enter key, you're going to see what router 1 is advertising to you. And I'll break this down once we get into OSPF, because I'm going to spend a significant amount of time on how this would work. But the basic idea is to understand how OSPF works, and I'm going to cover that. I just wanted to make sure that we covered it. And as you can see, there's nothing in here that tells you that it's a VRF, because right here, if you look at this with the MT is it MTID? No, I'm thinking router for the topology ID. So there's no multi-topology routing going on in here, which allows you to route based on QoS, but but there's no identifier here that tells you that it's in a VRF unless you knew it was in a VRF. Because if you did a show IP route, you're not going to see any of those routes show up. So then you're going to be like, well, wait a minute, where is it at? If you do a show VRF, then you're going to see VRF Lite's configured. It's got these protocols running for it, and it has these guys configured. So it's just one of those things that would make you think, if it doesn't show up in the global routing table, it's probably a VRF. So, but beyond that, that's pretty much all I wanted to show you. I hope this has been informative for you, and I'd like to thank you for viewing.